In January 2022, the planet Earth literally exploded. Deep in the South Pacific Ocean, the Hunga Tonga submarine volcano blew its top with the force of hundreds of nuclear bombs. It was the biggest atmospheric explosion that modern instruments have ever recorded. This thing was so ridiculously powerful, it sent a pressure wave circling the entire globe. Not just once, but 4 separate times. Tsunamis shot across the Pacific Ocean, and a plume of ash and gas blasted 36 miles straight up, punching through the stratosphere and literally touching the edge of space. But the real story, the one that's completely rewriting what we thought we knew about our planet, isn't the explosion you saw. It's what was hiding inside that plume. This volcano didn't just throw rock and ash into the sky. It launched a 150 megaton water bomb directly into the stratosphere. In one insane event, this volcano single-handedly increased the total amount of water in the entire planet's stratosphere by 10%. Nothing like this has ever been seen in recorded history. And for the last few years, scientists have been scrambling to figure out what happens when you do that, a mystery that started with a planet-shaking bang and is still unfolding high above our heads. We've all learned that huge volcanoes are supposed to cool the planet, right? Well, this one broke all the rules. Instead of making a giant sun-blocking shield, it shot up a massive puff of greenhouse gas. So, what happens when you inject the water from 60,000 Olympic-sized swimming pools into a layer of our atmosphere that's drier than any desert on Earth? The answer has been a wild ride of shocking and confusing effects on our weather, the air itself, and even the ozone layer that protects us. This wasn't just another volcano. It was a global science experiment we never asked for, and we're just now starting to get the results. On January 15th, 2022, a remote underwater volcano in Tonga that nobody had ever heard of suddenly became the most important place on Earth. Hunga Tonga wasn't your typical mountain volcano. It's a caldera, a giant crater hidden under the ocean, and its location was everything. The top of the volcano was sitting about 150 meters, or 490 feet below the waves. That turned out to be the absolute perfect depth to create a catastrophic explosion of magma and seawater. If it were any deeper, the ocean's pressure would have choked the blast. Any shallower, and there wouldn't have been enough water to cause this much chaos. But at 150 meters, the conditions were just right. Magma, burning at over 1,000 degrees Celsius, instantly vaporized a massive amount of seawater into steam. This created what scientists call a magma hammer, a series of insane blasts that shot a column of superheated steam, ash, and gas skyward at unbelievable speed. The scale of this thing was just monumental. The main plume went straight up, hitting an altitude of 58 kilometers, or about 36 miles. To give you an idea, passenger jets fly at around 10 kilometers, or 6 miles, above the surface. This plume screamed past the layer where our weather happens, blasted all the way through the stratosphere, and actually made it into the mesosphere. It is the highest volcanic plume ever recorded by modern instruments, a pillar of earth and water connecting the seafloor to space. The effects were felt everywhere, instantly. A sonic boom was heard all the way in Alaska, over 9,000 kilometers away. Pressure sensors around the world tracked the shockwave as it went past, and then again as it circled back, and again, and again. A massive tsunami with waves up to 20 meters high smashed into Tonga, while smaller tsunamis raced across the entire Pacific, causing damage and even deaths as far away as Peru. But while the world was still processing the raw power of this eruption, scientists were looking at satellite data, and they realized the biggest impact was completely invisible. They saw the lightning. At its peak, over 2,600 flashes per minute, the highest concentration ever recorded. They saw the shock waves rippling through the atmosphere. And then they saw the water. Something that was not supposed to be there. Not in those amounts, and not that high up. The real mystery was just getting started. In the world of climate science, big volcanic eruptions have a reputation. They're planetary refrigerators. The textbook case is Mount Pinatubo in 1991. Pinatubo was a monster eruption that shot 20 million metric tons of sulfur dioxide, or SO2, into the stratosphere. That SO2 gas turned into tiny particles that acted like a shield of microscopic mirrors, reflecting sunlight away from Earth. So when Hunga Tonga blew its top, everyone's first thought was, okay, here comes some cooling. But the data came back, and it told a completely different story. The eruption was shockingly clean. It only coughed up about 500,000 metric tons of SO2, a tiny fraction of what Pinatubo did. Any cooling from that would be practically zero. That was clue number one, that this was something new. The real what is going on moment came from a NASA satellite called Aura. It has an instrument called the Microwave Limb Sounder, or MLS, that can see through the ash and measure the chemicals in the air. Its readings were absolutely jaw-dropping. Luis Milan, a scientist at NASA's Jet Propulsion Laboratory, put it simply, "We've never seen anything like it." What the MLS instrument saw was water, a staggering, unbelievable amount of water vapor. When they ran the numbers, they were almost hard to believe. The eruption had launched 150 megatons, that's 150 trillion kilograms, of water vapor straight into the stratosphere. You have to understand, the stratosphere is supposed to be bone dry, thousands of times drier than a desert. But in just a few hours, Hunga Tonga increased the total amount of water in that entire layer of the atmosphere by about 10%. That's almost 4 times the water vapor that the massive Pinatubo eruption sent up. This discovery flipped the entire script. The question wasn't about cooling anymore, it was about warming. Water vapor is a powerful greenhouse gas that traps heat. Scientists realized Hunga Tonga didn't deploy a planetary sunshield. It had set off a greenhouse gas bomb in the sky. The Earth had just been hit with a massive, uncontrolled experiment. And the biggest question was suddenly, what happens now? The scale of this is just insane, and it's a perfect example of how our planet can still hit us with things we never saw coming. Now, back to the mystery. What does flooding the stratosphere with this much water actually do? So now scientists had a huge paradox. A volcano that was supposed to cool the planet was now expected to warm it. The powerful warming effect from all that water vapor was expected to easily beat the tiny cooling effect from the little bit of sulfur it released. For a while, this was a huge concern. Early studies were pretty alarming. With the world already hitting record temperatures from climate change and El Niño, this giant blast of heat-trapping gas seemed like the worst thing at the worst time. One study suggested the eruption could temporarily bump up the average global temperature, increasing the odds of crossing the 1.5 degrees Celsius warming limit by 7%. But as scientists got more data, the picture got way more complicated. More recent studies, some from mid-2024, have challenged that idea. A new analysis of Earth's energy balance found that in the first year, the cooling from the volcanic particles, while small, was actually stronger than the warming from the water vapor. This means the volcano's net effect was likely a very slight cooling, not warming. The scientific consensus now is that the crazy record heat of 2023 and 2024 was not the volcano's fault. It was overwhelmingly driven by human-caused emissions and a powerful El Niño. The volcano's impact on global temperature was just a tiny blip, but the temperature was only one part of the puzzle. That water bomb had other weirder effects. One of the biggest was on the ozone layer. The stratosphere is where a thin layer of ozone gas protects all life on Earth from the sun's harmful UV radiation. And it turns out, dumping that much water up there is a recipe for destroying ozone. First, all that water vapor actually made the stratosphere itself colder, cooling it by up to 4 degrees Celsius in the tropics. This happens because water vapor is great at radiating heat out into space at that altitude. This cooling messed with atmospheric patterns and, more importantly, supercharged chemical reactions that eat ozone. These reactions transformed normally harmless chlorine compounds into hyper-reactive ozone-killing molecules. The result was a direct and measurable hit to the ozone layer. In the weeks after the eruption, ozone levels dropped by as much as 5% across huge areas of the Pacific and Indian Oceans. In some spots inside the plume itself, the ozone was depleted by as much as 30%. This was the first time we've ever seen a volcano cause such a fast and powerful drop in ozone. This likely contributed to the unusually large Antarctic ozone hole seen in 2023. So, we have a volcano that scientists thought would warm the surface, but it might have slightly cooled it, while at the same time it cooled the stratosphere and chewed through the ozone layer. The next big question is, how long is this weirdness going to last? The good news is that most of these effects are temporary. The stratosphere eventually cleans itself out. The latest research shows that by the end of 2023, about 2 years later, the extra aerosols and water vapor had mostly returned to normal levels. The ozone layer is expected to bounce back from this short-term damage, The water that was shot up there doesn't just stay forever. It slowly gets cycled out, with a half-life of about 2.5 years. But while the direct effects are fading, the scientific impact is just getting started. Hunga Tonga was, without a doubt, the biggest natural experiment in planetary science of our lifetime. It gave scientists a once-in-a-generation chance to see, in real time, how our upper atmosphere reacts to a massive shock, especially one made of water. For decades, our climate models were all based on dusty, cooling eruptions like Pinatubo. They had no real-world test for an eruption that did the opposite. It's forcing scientists to completely rethink the role of underwater volcanoes, which were mostly ignored before. All the data from Hunga Tonga is now being used to build smarter, stronger climate models, ones that can actually account for these insane hydrovolcanic events. The eruption also uncovered some mind-blowing geology. Research on the seafloor found that the blast triggered the fastest and most powerful underwater avalanches ever recorded. These currents ripped across the seafloor for over 100 kilometers, burying everything in their path under a thick blanket of ash. It was a terrifying reminder that the fallout from an event like this stretches from the bottom of the deepest ocean to the absolute edge of space. The Hunga Tonga eruption was just an event of world records. The largest explosion, the highest plume, the most lightning. But its real legacy is the water. A single volcano that boosted the stratosphere's water content by 10% in one day. An eruption that sent a shockwave around the world 4 times, but whose biggest impact was an invisible payload of H2O that rewrote the chemistry of our upper atmosphere. While its direct impact on our climate seems to be fading and less scary than first thought, the scientific shockwave will be felt for decades. It blew up our old assumptions about how volcanoes work and forced us to look at our planet in a totally new way. It was a violent, powerful reminder of the incredible forces brewing beneath our feet and the fragile balance of the sky way above our heads. Hunga Tonga wasn't just an eruption. It was a message from the deep, delivered straight to the stratosphere. If you think this is as crazy as I do, make sure you subscribe and hit the notification bell. You won't want to miss what we find next.